Bismillahirrahmanirrahim. Sallallahu alayhi wa alihi wa sallam. Allahumma rabbi zidni ilma. Sallallahu alayhi wa alihi wa sallam. Ameen. Alhamdulillahi rabbil alameen. We should be nice to everyone. This is another important question of modulus inequalities, and we will solve this by using graphical method. So first we need to consider both the functions without modulus. Y is equal to 2x minus 1, y is equal to 3 minus x, and make the boxes for these two functions. Now let's sketch this function at first. So the coordinates are 0, minus 1, half and 0. Zero, minus 1, half 0. When we will reflect 0, minus 1 about the x-axis, we'll get 0, 1. So this is 2x minus 1 positive part of the modulus, and this is the negative part of the modulus, 2x minus 1 negative. Now either erase this negative part of the line or show it by means of broken lines. Now let's sketch the second function 3 minus x, and the points are 0, 3 and 3, 0. So this is the negative part of 3 minus x. Why? Because when we will solve this, we'll get x minus 3, and this line has positive gradient, and this is the positive part of 3 minus x. So make sure you write or label the equations correctly, because this line has negative gradient. Now we have 2 points of intersections, and remember, we always calculate these points of intersection. We never estimate these. So let's suppose this is A, and this is B. So for A, we need to solve these two lines, equations of these two lines. So 3 minus x is equal to minus 2x minus 1. When we will solve this, we'll get x minus 2. For B, we need to solve equations of this line and this line, because they are intersecting at this point. So this with this. So 3 minus x is equal to 2x minus 1. So we have, I guess, 4 is equal to x, 3x, sorry. So x is equal to 4 upon 3. So this is 4 upon 3, and this is minus 2. Now we have 2 possible solutions. Either this is the required part, or either this and this are the required parts. So if we suppose that this is the required part, then we will write the solution in this way: x less than equal to 4 upon 3 and minus 2. And if these two parts are required regions, then we would write the solutions in this way: x greater equal to 4 upon 3, x less than equal to minus 2. Now let's check which solution, this one or this one, is correct. So for that we need to observe where this graph, we must find where this graph 2x minus 1 modulus is above to this graph from the x coordinates of point of intersections. So we just need to observe where 2x minus 1. So if we check this solution, then see this graph is clearly above to this graph, and this graph is modulus 3 minus x. So for this solution, this is above to this, which is wrong. We need to find where this graph 2x minus 1 is above to this graph. So if we check this solution, then just check the y coordinates of these two graphs for the same x coordinate. So for the same x coordinate, the y coordinate of this graph is below or lower than the y coordinate of this graph. Y coordinate of this 3 minus x is less than the y coordinate of this modulus 2x minus 1 graph. And if we check this solution, just observe the y coordinates for the same x coordinates of both the graphs. Now see, it's very clear that y coordinate of this graph is above or greater than the y coordinate of this graph. So these two are the required solutions. This is not the right solution, because in this solution this modulus is above to this modulus, and for these two solutions this modulus 2x minus 1 is above to this modulus. So the required solution is x less than equal to minus 2 or x greater equal to 4 upon 3. So this is the way to write the solutions. You just need to observe where this graph is above to this graph from the x coordinates of point of intersections. Sallallahu alaihi wasallam. Ameen. Allah Hafiz.